consent when I do that?
No, it just shows an icon.
Okay. Okay, good. So it's official now. We started. Who wants to start? Do you want to, Ryan? Do you want to say anything about what you've been doing quite a lot recently?
Well, since last meeting, yeah, we've decided to I think add a another part of the database in the detection Docker, which will handle the raw accelerations, and so it's somewhere that we can save them. And then, so our next, what we decided the next part of the web application or building that is going to take those raw accelerations and then get them into the front end part of the app, most likely through some sort of API that we build ourselves. And then I also started working on a bit of a roadmap to get us to version 1 of that, which should include, adding the sensors table, adding more dashboard UI elements to it, finishing out the chart, making the chart more optimized, a whole handful of things to get us to a functioning version 1 of the dashboard. So as far as code-wise, I started looking at trying to get some of the of how we might start building that backend to connect the detection Docker with the backend API that we're building. But that's it as far as code. It's been a lot of been more planning.
Okay, and for those who weren't part of that sort of thread that we were having, is everyone more or less in agreement with this idea that we merge the dashboard into the Docker? That's what we're talking about, right? Merging it into the Docker instead of as a separate.
Yeah, I think it's there's kind of two use cases, right? There's running the thing locally end to end, so you can kind of see a whole system, play with things to figure out how data flows through. And then the thing we had talked about potentially doing is, okay, so what does it look like to have a distributed version of this thing where we properly have every process in its own container, running on Kubernetes and doing whatever we need to do with the database ends. So I think this is great because it's the first way for someone to get into the project, see things, kind of play with things, understand how it works, and then when they're ready to deploy or play around with a distributed system, there's kind of bridge up to that. So I think it's a great approach from my point of view, and I've been taking a look at it, Ryan. I'm acquainting myself with React, so it's been quite interesting. Thank you for providing that working example. So I think I kind of figured out what's going on, how it all works with Carbon, and then I had been playing with just instead of the mock GraphQL backend that you had in there, I just was playing around with just putting a Flask Python web application just so I could see how the two things interact together. So it's pretty fascinating getting back into front end development after so many years.
Yeah, no, that sounds good. It's front end development is weird these days. I feel like everybody's just throwing everything they can find into the kitchen sink, if you will. And I like. If anything with React, I like to try to keep it as much of just React, whatever's natively in React from the start instead of bringing in a lot of other libraries. But yeah, so that mock API will go away hopefully quickly because and it'll be replaced by, something like you just said, where it'll be some sort of other backend that delivers those accelerations.
Yeah, and I also started experimenting just with navigation in React too, which has been interesting in and of itself as well. Just so if we add other things beyond just a single dashboard, we've got kind of being able to, go from the SPA from one view to another. So a lot of me is maybe catching up and learning. So thank you for providing the working example. So it looks great.
Yeah, and I would say, I don't know if we want to include this in version 1 or version 2, but I would figure also the dashboard would have some sort of historical data component to it, right? Where one view would be the real-time data of the devices and the chart, and then the historical view might pull from whatever public data set we have, and you could look at any accelerations from any time in the history of the product, which might be another view.
This might be a good time then for me to just switch to this draft roadmap. If you can see this, like when I say draft, I mean I just did it very quickly, so not set in stone. Can you see this? I think what I was trying to get at here was this version 2 of the what you mentioned just now, Ryan. was that version 2 of the dashboard, you know, I'm not sure about the dates, I haven't calculated it, but the idea would be that the global information you've just mentioned would have to follow on from us having created the actual data set somewhere. And I think, Daniel, we were discussing this, know that this could potentially be hosted on IBM Cloud, just because, you know, Daniel can probably get us some credits for that. And that could be open, you know, for anybody to poll from. Is that right, Daniel?
Yeah. So we had looked at taking the whole system, provisioning Kubernetes cluster, generally running on either OpenShift, Red Hat OpenShift, or we've got a Kubernetes service too. So right now, folks can spin up a free single node cluster, but if we wanted to have a community instance that John and I basically have in our account that we run, that's one way to do it. Or we can create a OpenEEW community-owned instance and then grant credits to that. So a couple of different options there, and that would be for a way to people kind of either as just a test backend that they could work with instead of tainting the main production data. And then we also have the option for, you know, people using the steps themselves to set it up to run on Kubernetes.
Right. And so just go back.
Well, you could easily imagine people going down 2 of those paths, maybe 3, but we could probably pick one of the paths onto IBM Cloud. Do you want to do that, sort of you and I and Andy doing that, Daniel, or should we, you know, try to pick now?
I think we should probably think it through and kind of figure out what works, what we think works best. Just looking through a couple options, and then maybe we can have like the community take a look and see how they would prefer to work with it. But I think we need to have kind of a straw man of, hey, this is what we think it could look like. This is one option. This is how you would access it, play against it.
Right.
And then
I mean, the first option, you know, do it yourself. So you sign up for IBM Cloud. You can go and create a 1-node cluster, and then we give you the chunks of instructions to go and install that container into that cluster.
Yeah. So we have that step. That already exists. It's the 1-node free cluster, just the one Docker. And that the goal of that one is that you now have at least a public endpoint for your MQTT. But yeah. And what I'm thinking is you kind of have, if that's the development version, the single Docker monolith that has all the processes in it, if we then create a separate Kubernetes cluster, multi-node cluster, Kubernetes OpenShift thing, that is where the community can kind of, that's like a reference endpoint. And then the third thing is, okay, I want to run a local EEW for New Zealand, Nepal, whatever it may be. Here's the steps I have to recreate that myself with my own data for that community. So that's kind of one option for it too. Is like, here's your deployment YAML, go apply it against this of your own endpoint. Or if you're a university kind of studying the thing yourself, you know, you can kind of do that too. That's what I'm thinking.
Okay.
Yeah.
So I think that you do here is maybe Andy, if John and I kind of put our heads together, we know about OpenShift best practices. We can then kind of propose what this would potentially look like, and then we can bring it back before one of these town halls or a TSC meeting and kind of figure out, you know, what to take forward.
Great. I think we have much more clarity than we did in our first town hall about the separation between the private user networks and the global data set. So yeah, that would be great.
Yeah, and then the end goal, you know, the fastest way for somebody to let alone play with this, but also set up their own without being destructive to the core data set, I think is kind of the real.
One thing for everyone to realize is that we're sort of looking at Puerto Rico as a sort of test example. I mean, hopefully it'll be more than just a test example, but something that I think people will be able to sort of really interact with and understand the nuts and bolts of this whole system. And then if you're going to do a similar system in Nepal or New Zealand or Chile, you can use it as a reference almost, as a working reference. So that would be hosted in the cloud, right? And that would be as accessible as possible without people being able to send false alerts.
Exactly. Yeah. And so that'll hopefully give us a recipe that anybody else can then follow later. So yeah, very excited about that. So so just to give you a heads up, so IBM is funding, we've got some money for the next generation of the hardware that is being created. So the new sensors, kind of next generation, but also deploying those in the Caribbean, trying to figure out how we expand from our footprint we have in Puerto Rico to potentially Dominican Republic and the Virgin Islands, so that we kind of have some stakeholders in each area. And Pedro from our team in Puerto Rico has been talking to a few public and private partners in Puerto Rico to kind of host some of these. I think they did get actually one of the a large bank down there to install one as well within their location. So really exciting stuff, and kind of expanding that footprint with kind of this next phase of what we're supporting on the IBM side.
Great. And for those who are, I know we have people waiting for sensors. So for those who don't want to make PCBs, the good news is we have two people. One is Rafael, who's trying to join now, but he's been kicked on and off. I don't know what's happening. He keeps sending me network error messages right now. And then the other one is Gareth, who came in through John at IBM. And both of those are sort of trying to debug the issues we have with the current board. The hope is that we will get those issues sorted out very soon. I'm being optimistic, maybe in September, but as soon as possible. And then we will, using some of the grant funds from IBM, make a first batch to test them, and then from there we can actually start doing a full production run. That's the idea, and I think I think it should be okay. I think we should be within a couple of months of that. And then in parallel, Arrow Electronics is helping us with version 2 of the firmware. So if you look at my sensor roadmap at the very end, we're sort of working towards a new design, which may not be using the ESP32. I mean, this is open to discussion. It might use an I.MX, a new chip from NXP, which is much more powerful, modular, future-proof. It's probably more professional type of microcontroller. So I'll let you know how that develops, but we're sort of working in block diagrams right now.
I don't have an opinion on that NXP device, other than curious on the price point.
Yeah, it's actually a tiny bit more expensive. I mean, $1 or $2, and the reason, and I think I've been having this discussion a lot in the last couple of weeks, because I had the same question: price is everything. But I was sort of bought into this argument from the engineers that the ESP32 is very, very limiting in some ways, and so this other one, if you want a more powerful version of more memory, you can just swap it out without changing your PCB. If you want a different radio, you just add. I mean, you add the Wi-Fi, or you add something else, or you add more flash memory. You can really do what you need to, so you're not constrained. So if we wanted to do edge detection, really run sort of micro models on it, you can do that with, maybe not with the ESP32. So I'll once I have more information, let me put it on the chat in sensors, and everyone can comment on this.
Okay.
Who else? Mark, do you want to talk more about those areas of interest that you had, and maybe we can discuss those?
Sure. Yeah. Thanks. I'll just go to my post and kind of scroll through it. I mean, so what I did is I just went through all the stuff I could find that you guys had online. I didn't go super deep, but then I just tried to brainstorm a couple of ideas. And the first one there was, so one thing I saw, which makes complete sense. I'm just coming out from the outside, but like you need to determine when something's happening. So there's a lot of noise much of the time. So I don't know if that's a difficult problem, but maybe just trying to look at some of the data and kind of saying, okay, at a sensor level, trying to do different things with the averages. It's the same. Maybe there's some kind of seasonality in the noise, different times of day, certain times of the year where there's more noise. I don't know if you guys have solved that, if there's any opportunity there.
Well, we've only got one seismologist on the call today, so Vaclav, do you want to comment on that?
Yeah. Noise levels generally differ during the winter and during the summertime because of the noise coming from the ocean. So that differs. But at this sensitivity of the instrument, I don't think it's going to be a huge difference. I think it's actually going to be quite the same. So yeah, I wouldn't expect there to be a huge difference seasonally. Yeah.
And then what about like things that are in noisy areas, like trucks or other things, or like certain sensors getting more noise than others?
Yeah, more sensitive sensors are going to pick up more man-made noise, that's for sure. So in general, you should try to deploy sensors in areas that are quiet, farther away from roads, farther away from rivers. Rivers are a huge source of noise. So that's for sure. You should try that. On the other hand, what you are trying to detect, those earthquakes are quite strong. So yeah, ideally, those would be easily distinguishable from man-made noise. Yeah.
Got it.
So is it true that every device sort of needs its own little set of calibration? Because, you know, noise in one location is still going to be, you know, but it's going to have a different signature of noise in a set, you know, different location. Maybe it's closer to a river or, you know, outside of a main highway.
Yeah,
so calibration.
It's going to look different. I wouldn't say that it's a different calibration as long as it's the same sensor. It's going to be calibrated in the same way. And the earthquakes are probably going to look quite similar. So
yeah.
the detection should be very similar to different locations. I think it's good if we are going for some kind of more sophisticated detection by a neural network or so. It would be good to train this neural network on the particular sensor or on the particular network that we would have the same. It would be detecting the same kinds of signals that it would be trained on. So it would be probably good to do. On the other hand, it's probably not necessary because earthquakes are looking fairly similar, especially in these first several seconds. They look fairly similarly in different locations. So it probably is not necessary. Absolutely.
Right. Yeah, I would say that that yeah, the first thing you said, which was very interesting, was we tried not to put them in noisy places. You know, I always thought that one of the benefits of our sort of IoT low cost approach is that we can be less choosy about where we put them, because ultimately we have more of them, and you can use multi-station confirmations, for example. So I sort of think, you know, you would, well, in our case anyway, in case of Grillo, we would be very limited if we only chose sites that had very clean signals.
Oh, for sure, yeah.
We had to put them in schools, and we had to put them, sometimes you just don't have any other buildings that have power or internet. So you have to go to these noisy places.
Yeah, definitely. The way you do it with broadband stations, with those highly sensitive seismometers, you normally want to go somewhere where there are some people so they can guard the station, but it's several hundred meters at least from the road and from houses and stuff. But those sensors are several orders of magnitude more sensitive to all kinds of noise. And also, if you are trying to pick up very tiny earthquakes, you are trying to pick up, you know, all sorts of signals that are very weak. But for this kind of a system, as you say, a good connection to the internet, to power, is primary, and the number of stations is probably going to, the quantity, not the quality of data, is going to be important. So definitely.
Yeah, so maybe to step back a little, thanks, that was helpful. The program I'm doing now, is in data engineering, and so we've got like 60 people in it, and we have like 4 or 5 TAs. So they're very good, these the TAs, and they're very. One thing you point out to me is like, well, I mean, I guess with any data application, you want to know like who's going to be using this and what the use case is. So, like, it's not enough to just say, okay, some data science person is going to do something, but to try to identify who that person would be. It's like, would it be a seismologist? Like, would it be someone like you? And then, kind of like, what are their problems or what are their questions? Because I guess the goal, or the way I would try to contribute, is to try to clean up the data or stage it somehow in a way that people could do, you know, interesting kind of analysis or modeling things with it. I just don't know what all those use cases would be since I'm new.
I would say there's 2 things there, Mark. One of them is, from my perspective anyway, one of our goals is to try and clean things up on the sensor itself. I think that's further down the roadmap. We are, you know, we've had this discussion a few times. We're sending all sorts of data that really isn't useful, you know, because we only care about earthquakes. And we're sending stuff all the time. So further down our roadmap, you know, it does make sense to add some filtering or some algorithms on the device that will only send data after a trigger has been met.
Right.
I think that will reduce, significantly the amount of stuff that we have to deal with.
Mm-hmm.
In the short term, though, we could be running that in the cloud anyway.
Right. So, like, what about like profiling things that have happened? Is that easy with the data set you guys have? So identifying, at a certain threshold, there's this many, I don't know what you call them when it's not a major earthquake, like a tremor, and then how long it lasted. Like, is that pretty well developed right now?
Yeah, I would say there's one thing that we desperately could use from, because one of the issues we've had is people want to use our historic data on AWS, but it's just a bit intimidating because there's so much of it there and they don't know how to go through it. So one of the things is to try and cross-reference some of these catalogs that we already have. In fact, the OpenEEW website, I don't know if you've been there, Mark, but at the bottom, there's a sort of page I wrote about machine learning. In there, I talk a little bit about, from memory, I might be wrong, but I think I talk about a catalog from the Mexican Seismological Agency. It's sort of like the USGS. Every country has one. And from there, you could flag all the earthquakes in the data that we already have. And perhaps
that would be cool. Yeah, so like tagging that. So there's something of earthquake database somewhere else and linking that to your data.
Yeah, and then maybe that could form part of the data set as a way for people to reference them.
So Andy, I had to-do GitHub issue opened sort of in my Node-RED repositories because I have so Mark, coming in late for a while ago, I built a little dashboard, lets you pick an historic data set. So go back in time, pick a year, pick a month, pick a day, pick an hour, pick a 5-minute interval in that hour and say plot. Right. And it goes up to AWS and pulls down that chunk of data, draws the graph for 5 minutes. And then there's another button that says next and another button that says next. So if you know where to look, right, pick a day that there was a big earthquake, February 16th, 2018, 11 p.m., 2300 UTC, blah, blah, blah. There's a graph. And now you see an earthquake 7.2. And then if you go next, you get the next chunk of data and you see all the aftershocks. So, but what happened was, and Andy told me about that particular day, and Pedro told me about some of the earthquakes in the Puerto Rico data set. And so on a piece of paper, I've jotted down interesting places to go to actually, instead of me looking at noise in my dashboard, I can actually do a demo where like, oh, here was an earthquake on this particular day and it looked like this. And, it had a whole bunch of XYZ accelerations. It's relatively straightforward. And I also have a real-time one that says, we're just going to detect what a shaking event looks like, certain number of standard deviations beyond noise. Mm-hmm. I could easily write a little program that trawls through all terabyte of data and finds data, days and times that exceed that whatever range is.
Right.
So I have a GitHub issue, and it's a relatively small program. Sort of in my mind, I know how to do it. Probably would take an hour or two of actually, writing the code. But I'm sort of as a side project. And I'm like, it would be fun. But if people really need that, Andy, if you need that, or Mark, if you need that, I can bang that out. I don't think it's going to be too hard. Now, what I would give you, though, is like a table of times and days and sensors. And then you can click on the whatever, pick one, and then it would just go graph it. And then you could go look at it. Now, I'm not doing other than here's this big long table. I found it. Click on it, graph it. I'm not going to do any other analytics on, the why. And I just think that my algorithm found one. Mostly it's not going to be a truck if I pick,
high enough threshold.
Deviations. Yeah.
Mm-hmm.
So what would be probably a conventional seismological approach would be to do some STA if we want to do it automatically, it would be to run some STA-LTA picker, and then to run it on all channels, or like all the seismometers, all the stations, and then do some kind of association of those peaks, and then location of earthquakes that are most likely earthquakes. So creating an earthquake catalog, which you don't have to do, you can do fairly automatically. Or also, if maybe like a seismology student could do all the picking, because it's kind of time consuming to do at 20 stations, 30 stations, or how many we got in a year. So, but going through and actually picking every single P wave and S wave would really help to get a clean catalog. And then maybe it would be a good idea, if you want to try different kinds of detections, to have a hand-picked catalog or hand-picked phases that would be actually very precise, and we would know for sure that those are the target phases that we want to pick by any kind of algorithm in the future. So maybe spending that time, would be worth it, but it's something probably to discuss with Diego too. But that would be kind of like a approach from
yeah. So I'm just throwing a brute force approach at this, and I could probably knock something out. But getting to that level of sophistication of, can I do an STA-LTA across multiple sensor correlation? There's another ticket I have open for that too, but that's a harder problem.
And that's maybe the kind of project that I could do if you guys needed that. I'd have to look more into it, but
I wonder, John, though, it sounds harder, but isn't it true, Vaclav, that we have a Python library at OBSPI? OBSPI is like a seismological library. There's ready-made scripts for getting these pickers. Like, I don't think we have to necessarily do it ourselves, right?
Oh, no. It's fairly standardized in seismology how this process works. So you get the picks, you associate the earthquakes, you locate them. So it's very standardized, and I don't think that in this area we would have to reinvent the wheel.
Is this something you could help us with, Vaclav? Maybe create some instructions for somebody who's not who hasn't gone through all your education in seismology, to sort of just some basic steps for how you would deploy this picker and get the output.
Yeah. I think it's probably like doing the OBSPI and stuff there would be some kind of a learning curve with that, but yeah, for sure. Yeah, I could do something like that.
Yeah, I actually looked at the Python libraries, and I said, because I was looking for the algorithm that I could use, because I'm a Node developer, so although I can read Python and write Python too, but the app that I was building in the dashboard was in Node and Node.js. So I'm looking to port that was now not the entirety of Psi over to Node, but I just need to find the STA-LTA algorithm, and it's big. The Python libraries are quite sophisticated.
But there is a simpler version of it as well, though, John. So, like in the Docker detection, I think Luis coded up a very basic STA-LTA, which is simpler than the one in OBSPI.
That would be useful. Okay.
And in fact, when we employ people in Grillo, we give them a little test, an online Google form, in which they have to create their own STA-LTA, and we ask them to do a notebook and share it with us. And we make it really easy. We give them some really simple pseudo logic for it. So maybe I can share that as well. But I think if someone explains it well, and you don't need to know what S wave and P wave mean, you can sort of get a hang of it.
Yeah, I'm not a seismologist, and you guys are much smarter than I am. I'm just a developer, and I'm like, here, give me a pseudo algorithm, and I can turn it into a block of code. That's what I need.
I'm going to post it. Yeah.
Okay, cool.
Hey, we've just got two new joiners. Hi, Gareth. Hi, Raphael. I think you're both on mute. But
yeah.
And it's great because you both have been working on the sensor hardware, so it's great that you could join us.
Yeah, and is this your first call? If so, we can go through, I guess, the introductions round and have Mark also.
It's the first call I joined, but I've watched the other recordings, so I'm not too far.
Yeah, this is Gareth. This is my first call.
Great. Well, do you want to talk about what you guys were doing? I know, Raphael, we had some trouble sending you the sensor because of customs, so you haven't looked at it yet. But you already helped us with KiCad and getting the schematics improved.
Yeah, I'm not sure what to talk about. I'm already familiar with the hardware because I've redrawn the whole schematic and I've seen the PCB files you made of the previous revision. Now I was just waiting for customs to clear that in order to test the changes before making the new revision, the actual PCB.
And I think Gareth was already starting to look at this, right?
Yeah, I've been looking at the board, trying to see where the best place is to fix the link to the PHY. And before that, I was reviewing the schematic to see if I could see anything we could improve.
Were you able to sort of make the change in the traces and reroute those two pins, or was that too fiddly?
It's too fiddly with the stuff I've got at home. We're not allowed to go into work. We're not allowed to go into the lab. So I'm sure I've got some good wire around the house somewhere, but I don't know what it is. It's like it's been 20 years since I brought the wire home, and now
Well, I ordered some of this blue wire you mentioned in the chat, and I'm going to see whether I've got a really cheap USB microphone that I bought on Amazon. I don't know if I can reach it over here, but I've got to see whether this thing could do the job. My eyes aren't good enough otherwise.
Yeah, I've dug out a magnifying glass from the drawer.
Yeah, well, the hope. Here's a question for you, Gareth and Raphael. How do you think we can get to the next stage here? I mean, with the changes to, if we can debug this problem with the Ethernet, and I think Raphael already has made some changes to the NeoPixels and the buzzer. Are we good to go for the next test run? If I order another 5 boards of those, what would make you comfortable in terms of testing the Ethernet? Sorry, I've got a cold here.
Well, assuming it's just the issue is not complicated, I would modify this current revision into actually connecting to the internet. And if that works, everything else should be ready to make another revision.
And I reviewed the changes from the Eagle files to the KiCad files, but to a certain degree of there was a lot of, it was quite different for me in the schematic. You made it look neater actually. Are we comfortable in that translation from Eagle to KiCad?
Well, personally, I am pretty comfortable with the conversion I made, but that's not for me to decide if it's okay.
Yeah.
Maybe a couple reviews would be helpful.
I've compared the current circuit in the schematic to other people's circuits, and it looks pretty much the same. Can't see any difference.
Great. We had a comment. We had a pull request today from somebody regarding placement on KiCad. I don't know if you guys have looked at this, but I wonder.
I have not seen it.
Yeah, I'm gonna post it here. But I'm not even sure who this is. But it's great. Looks like somebody has identified something with the capacitors.
Right, I cannot see the actual changes, but it seems they added I'm not sure what's going on here. None of the routing has been done yet, and none of the layout has been made, so I'm not sure what there is to improve.
Oh, this relates to the layout, so I thought it was about the schematic, right?
Oh, I'm
Oh,
not sure, actually.
Okay.
Look further.
Okay. Great. So, anything else, guys? Do you guys, Vaclav, do you want to talk about Nepal?
There's not that much new about the project. We are still with the partners in Nepal. We are still trying to find money for that. So in Nepal, they are talking to some development organizations that provide some funding. So I hope that that goes well. And also regarding the system, I would like to get in touch with Luis and Diego to call together and kind of talk about the seismological part of the system, and maybe make some kind of a roadmap to work on seismology, because I don't know how you guys think about it, what should be, how that should be designed, because normal earthquake early warnings, they have this component of rapid estimation of location of earthquake and magnitude, and then based on that magnitude you calculate the intensity. So if that's how the system should work eventually, I think I could probably start building up these algorithms for the rapid, you take first couple of seconds of the P wave and you estimate quite roughly, but location and magnitude. And
so if that could be done, that would be awesome. But I would say that we have had a shot at this. So this is definitely Luis Diego territory, not me. But we have had a shot, and we got it wrong. So we actually had an algorithm developed by one of my early advisors, who was the head of seismology at UNAM in Mexico, and he, American guy, Alan Husker, and he wrote us a really simple algorithm which first of all worked out the location by triangulating 3 sensors. Actually, it would get better and better. As a new sensor detected a certain threshold, it would add that to the algorithm, and we would then work out using matrices or whatever it was where the epicenter was. And once we had the location, we would then work backwards to find out what the magnitude was by working out the energy at each individual station, and then where it would be in the epicenter. So we had a pretty good system, and we've got this coded up. I can put the code on the website for you to look at. The issue we had was that we didn't trust the device time, and if the device time isn't correct, then you're gonna miscalculate the location, and so because it's all about the vectors are determined by time, and so we realized the issue was that we weren't using GPS, that our modules rely on NTP, internet time, and internet time, depending on where you are in the world and what's going on, can be 500 milliseconds, in terms of drift. And that drift was killing us. And so we would sometimes be estimating the epicenter and therefore the magnitude, 100 kilometers away. And that would completely throw off everything, would get ridiculous magnitude estimations. So I sort of feel that the problem we always had with that was the hardware. And so I wondered whether the way to counteract that would be to have many, many more devices. So maybe we don't have the time as accurate, but if we have many devices, we can instantly disregard devices that are outside of the range of time of the other devices. That's sort of we were moving.
Yeah, timing is definitely an issue. So if you have half a second of uncertainty in time, it gives you, like in the worst case, it gives you a P-wave velocity is about 6 kilometers per second. So it would give you 3 kilometers of mislocation, roughly, very roughly. So more sensors will give you more precise triangulation. And also, I don't know if that algorithm was running on that network in Mexico. It's also a network that is not really great for locating earthquakes because it's a line on the coast. So for precise location, ideally, you would have a network that would be constructed around the epicenter. So it would not be a line and an earthquake would be happening somewhere on the right or left side of the line. But it would be a network that would kind of triangulate it within the network. So it's always, with location, it's always a problem when it happens outside of the network. So I think that would help. That would help too. So what I was thinking, I still need to talk about this with Diego, but I could, if I could try to like write these algorithms. We have a lot of data actually from that aftershock sequence in Nepal, where we had about 50 stations, and maybe testing out these algorithms on some existing data when we already have thousands of earthquakes that are very well located from conventional seismological methods. So testing these algorithms, maybe also introducing these time errors and doing these things, we can also test the detections and stuff like that. So maybe we could try that out. But
if you were to do that, definitely speak to Diego, because he once said to me that if we were going to devise algorithms using data which didn't come from our own sensors, we would have to add artificial noise into the sensors to sort of simulate what we already have, because otherwise it's not apples and apples.
Yeah, absolutely. It should not be adding the noise. It should not be that difficult. But I definitely want to talk about these things with Diego, because he's much more. He knows much more about earthquake early warning systems. I'm catching up on these things. So, it's not my field entirely.
I would say though that before we go too far down comparing us to a normal system, I would say that Diego has criticized normal systems in the past. Like one of the big problems that the Shake Alert has in West Coast America is that they have a huge amount of false positives. They might have fixed this, but they have such sensitive equipment that a lot of the algorithms are just trying to get rid of events inside of that very high BAM. We don't have that problem because we have an automatic cutoff due to the limitations in our sensors. So, a lot of the work that they do, we don't have to do to some extent. But yeah, Diego's the expert.
Yeah. I really might be looking at it from like really seismological perspective, but I think it would be good to have those algorithms there, because then we can do, Shake Alert is publishing those warnings with how fast the warning was issued, what was the misfit or uncertainty of the magnitude in the early seconds and stuff like that. And I think it would be quite nice to have it in there, some kind of algorithms like that. So, and
ultimately, would this feed into the Docker system that we have? So, like the algorithms, I think the way Edigio, I'm going to mispronounce his name, the way he had devised the Docker was that we had modularized these components. So presumably, this could just take the place of the STA-LTA Python script that we're running.
Yeah. And I think that's probably something to talk about and think about how this whole system is going to be designed and how it's going to come together. And yeah, that would be really nice to create some kind of a roadmap of this, and so I can contribute with the codes from the seismology, but also use your guys' experience and knowledge about the programming stuff.
Daniel, didn't you once mention working groups? How could we organize this so that the detection investigation, the Docker investigation, the electronics engineering investigation, how are these things going to run in parallel, so we don't have to interfere with each other too much?
Yeah, so working groups, they're very good for larger open source projects, I think, that have gotten to a good mass, just to make sure the conversation doesn't get too unnecessarily fragmented. But I think in this case, even at the size of the project, it makes sense because we do have different specialties. The channels are obviously a great way to kind of segment the conversations. The next step would be if there's a need for, a secondary meeting to this town hall, maybe, the working groups meet the alternate week or something like that, or they can be ad hoc. But, just thinking about kind of the three different things. So there's obviously the channel, there is the repo with any sort of README on the current topics and schedule, how people can join it, kind of how the discussion goes. And then finally, if there is a need for a weekly call. So I think, making kind of a proposal at that is a good start. And in fact, maybe the good place to kind of start to document it, I just started drafting over on the main OpenEEW repo. I created a wiki there to start talking about the Kubernetes deployment ideas that we had just talked about at the start of the call. So maybe we can kind of propose some ideas there, and that kind of just a free form yet still visible to everybody, place to put that information. So here's add, for example, proposed working groups and kind of use that. The challenge obviously with the wiki is you need to be part of the organization to edit it. Therefore it's a little more trustworthy in terms of provenance of what's put there. But anyway, we got a bunch of tools we can talk about. Maybe we we just could start the conversation in general, start to capture and consolidate the ideas in the wiki, and then use that as kind of the starting point. But again, we wouldn't want to segment too much of the conversation if possible, but obviously where things are seismology related that don't need to be on this call, or dashboard related, front end, or sensor related, I think we've got already some subgroups that are ready to get going.
Yeah, great. Before we get into the wiki, I'm just going to say that the Linux Foundation folks, they are going to put us on the beta program for the discussions in GitHub. So
Okay.
we can think in many ways that offers more than the wiki.
Great.
So we can have corresponding discussion forum groups in GitHub for each of the channels.
Awesome. Yeah, I haven't used that. How open and how widespread is that beta?
I haven't seen it many. If you go to the GitHub discussions blog post, they give you some examples. It's nice because you can reference issues and pull requests, and I like it also because my issue with Slack is that as well as we can use it and as well as we do use it, it becomes a bit noisy sometimes, and you can't refer back to problems very quickly through search. So I like the idea that people can create something in the discussions forum and it lives there forever.
Yeah, and this was, I was thinking about adding, and this gets noisy too, though, subscribing to each of the repos from each of the specific channels. I know I raised the idea with you, Andy, and I kind of was hesitant to do it because I know that you can do it on commits, you can have it on the whole conversation, so everything is unified. But yeah, it quickly burns through your 10,000 message limit,
Yeah.
and you lose the history altogether, which is not good either. So anyway, I think maybe it's just one of those discussion items. Maybe we just need to come to some ideas around.
So we're almost at the end of the hour. I don't know if anybody has anything else they want to say.
I just had a very practical question following up on that. So should I, like the type of questions I was asking, would seismology be a good channel for that within Slack? I don't want to spam the wrong thing.
Yeah, I think we do have a seismology channel. I would say there,
Yeah.
it's definitely intros in general, and then just say, just mention in general, you're bringing the conversation over to say seismology, and I think anybody wants to follow you there who's
Okay.
not there, because I don't even think I'm in that channel, or am I? Oh,
In fact, I think you're right. It should actually be called seismology and data, or just data, because it is relevant to the data. I think it's a good place. Yeah.
Cool.
So to follow up on that pull request, this contribution apparently was made with the latest version of KiCad, the nightly build. I'm not sure that's the right move. First, does really make sense? I used the latest stable version. Yeah, that's about it. I was trying to open it, but since I have to install the nightly version, I'm just now being able to open it. But
can you leave a comment in the issue?
yeah,
So
I've already commented on the issue, asking about why we used the nightly version.
and we've had a lot of people, John, having issues with Node-RED installations. I know Gareth had an issue. We had some other people.
Yeah, Gareth worked through his, right? And I think that was a Windows install issue. And then I saw there was another question about installing Node-RED. I couldn't tell where Nuwan was trying to do it. Was it in the cloud or whether it was on his laptop? He gave a URL which implied maybe a cloud offering. And, depending on how you've stood up that particular node container, whether you can install from npm or not. But Gareth, I wanted to make sure we didn't actually chat. I saw that you gave a thumbs up that it was working for you. Did you get it going?
My only problem was with PowerShell. PowerShell is the only shell which implements some security, which means that you're not allowed, under certain settings, you're not allowed to run any scripts in the PowerShell. And for some reason, my PowerShell had that option. And the error message did point me to a place where it taught me about it and what to do about it. And then I stopped PowerShell. I just used the command prompt instead.
I do have a couple of examples that you might want to jump in and take a look at. I can help you with. There's a node. There's an OpenEEW Node-RED repo.
Okay, yeah, I'll take a look.
Yep, I'll shoot you some links.
I think the first thing, Gareth, that I think you mentioned was just you wanted to see the data, right? So I had mentioned, John, just an MQTT in node and a debug node, just to sort of make sure that the sensor was actually working.
Yeah, I want to see the trace and then how much noise it's got on it, then put another capacitor onto the accelerometer chip to see if that reduces the noise, just to satisfy myself that it doesn't make any difference.
Okay. I could do that on mine as well, because I had it send in MQTT data to just a local. Do you have a local broker someplace from the board to a local broker on your private home network? I'll teach you how to set it up if you want.
Yeah, I think I shared with Gareth a link to the Mosquito download, so that would have installed your MQTT on your laptop.
Yeah, that's how I did it too.
Yeah, I've got Mosquito run, and the MQ in seems to think that it's connected. It's just there's nothing coming in the debug channel.
Okay. All right. Well, I'll connect with you in a Slack discussion, and we can work that through.
But it's a good point, actually. And in fact, what I might do, John, if you agree with this, is I might, in the README for the Node-RED, just add the most basic thing about connecting an MQTT in Node and just seeing the data. Or do we have something like that already, just to see the data? No, well, because really I haven't tried to wire Node-RED to one of the real sensors. I was mostly going against the AWS data set. So the repo doesn't mention anything how to connect to the actual sensor. Okay. Considering there's only a dozen of these in existence, right? Four of these. 4. Okay. Okay, folks. Well, I think we're past our hour. Don't know if anyone else wants to say anything else before we finish. Yeah, I got to run.
Thanks so much. Appreciate it.
Cool.
Thanks for meeting, everyone.
All right. Yeah, thank you.
Thanks. Bye.
See you in a couple weeks. Bye,
guys.
Bye.